All right, let's go through a few problems to prepare for a test on quadratic equations and quadratic functions. I'm starting at number 8 because some of the stuff up above was all imaginary numbers. So let's just start with quadratic equations. Quadratic equations are when you have an x squared as part of the left side of the equation here. There's a couple different ways to solve these. First thing I always look for is to see if maybe, just maybe, you can factor it. And indeed, x plus 5 times x plus 4 does equal that trinomial on the left. Now you can set each factor to 0 separately, branch it off into two equations, and you get your two answers, which are the solutions for this quadratic equation. So I always look for that factoring method first. Now on number 9 off to the right here, I see that there's no middle term, so I'm thinking I can either factor it or I could use a square root on both sides. So if I divide both sides by 9, I get x squared equals 4, and then I could hit it with a square root. And remember, whenever you square root both sides of an equation, you always get two answers. Plus or minus 2 would be the solution there. The directions on this problem tell me what method to use. I'm going to use the completing the square method. Now that's where we make a little space. We move that 11 to the other side. So x squared minus 4x, we'll leave a little space there for now. You guys have gotten really good at this, right? We'll go to the next line. We'll create our perfect square by dividing this number by 2. So we're going to go down here and we're going to put negative 2 here. Then we go back up to where we left a little space and we'll put a plus 4 right there, which is negative 2 squared. Now, whatever you do to one side, you have to do to the other, so I'm going to put a plus 4 on that other side. So we got negative 7 on the right. I'm then going to square root both sides. I square root both sides, I get x minus 2, and we can't take a square root of a negative, so we introduce that I, imaginary number here, so we have I radical 7, and because we square rooted both sides, we do get two answers. We then add 2 on both sides, and our answer is what we call a complex number. It has a real part and an imaginary part, and there's the two complex solutions, and we found that by completing the square. Let's go to the right. Let's see how this one comes out. We're going to complete the square again. So once again, let's move that 12 out of there because that's not the right number to complete the square. Right? We want to complete the square by putting the magic number there that creates a perfect square. And the way I like to teach this is to figure out that number, you take that and you divide it by 2. And then you go back up here and you square it. You put 5 squared up there, which is 25. Now, whatever you do to one side, you have to do to the other. So on the right side, we have 37. We then square root both sides, and we get x plus 5 equals plus or minus radical 37. 37 is a prime number. It can't factor at all. So that can't simplify. We're going to minus 5, though, on both sides. So x equals negative 5 plus or minus radical 37. And there's your two answers right there on this quadratic. So that's solving quadratic equations by completing the square. Now there's this thing called the quadratic formula. You remember the answers are opposite of b plus or minus giant square root of b squared minus 4 times a times c, so minus 4ac all over 2 times a. And that's where your a is the number in front of the x squared, your b is the number in front of the x, and your c is here at the end, so that would be negative 12. So let's see how this works out. The opposite of b plus or minus giant square root of b squared is going to be 64. Whatever number you put here, it's always going to be positive, okay? Negative 8 times negative 8 is positive 64. Now here's that danger zone that I've talked about. Negative 4 times 3 times negative 12. All of this is under the radical, all over 2 times 3. So be careful in this danger zone. Take your time, get your signs right. That's where students often make an error if they're going to make an error. So the answers are, let's keep going, 8 plus or minus. This is 64 plus, we have 48 times 3. I don't have my calculator handy, so I'm going to do this there, 144, all over 6. So x equals 8 plus or minus the square root of 208 all over 6. Now that can simplify, but I'm okay if you get to that point and you leave it like that. I'm pretty thrilled. You got your two answers using the quadratic formula. Let's do another example with the quadratic formula. You notice how this is not in the right form, so we're going to have to distribute first. X squared minus 3x equals negative 5. So x squared minus 3x plus 5 equals 0. How did I do that? I added 5 on both sides. Right, added 5 on both sides. So now I see A is 1, B is negative 3, and C is 5. So opposite of B, the answers are, that's the nice thing about the quadratic formula is you just plug it in and boom, you got your answers. So 3 plus or minus giant square root of 9 minus 4 times 1 times 5 all over 2 times 1. That is 3 plus or minus the square root of negative negative 11, because 9 minus 20 is negative 11, all over 2. So let's write our final answers as complex numbers, 3 plus or minus I radical 11 all over 2. Or you could write it 3 halves plus or minus I radical 11 over 2, or you could write the radical 11 over 2 in front of the I, might even be better, honestly, but we'll go ahead and circle that. So we got an imaginary part to this, so it's called a complex solution. The discriminant, you remember what that vocabulary word means? It's the b squared minus 4ac part. So you take your b squared, that's 25, minus 4 times 1 times negative 1. We end up getting 25 plus 4, that's 29. So the discriminant here is 29. Now, when the discriminant is positive, you get two irrational solutions because it's not a perfect square, by the way. So we get two irrational answers. They're going to be non-repeating decimals. If that had been negative, by the way, then we would have gotten two complex numbers. If the discriminant is negative, you get two complex. If the discriminant is 0, you get one answer and only one. If 29 had been a perfect square, we would have said, oh, we get two rational numbers, like integers or maybe fractions. Okay, so let's look at a graph a bit now on number 16. It says for the graph y equals negative x minus 3 the quantity squared plus 4. That's vertex form, folks. That's vertex form. So one of the first things I'm going to do letter C first. The vertex here would be at h comma k. So h is your 3, that's after the minus sign. Remember, you always have to change a sign when you pull that out, comma 4. So on my graph, I can go over 3 up 4 and label that with a V. Now, will this graph open up like a cup or will it be concave down like a frown? Well, since the leading coefficient is negative, so since A equals negative 1, it's going to open down. That's just something you might want to note as you're doing this. All right, let's figure out the actually, the axis of symmetry would be easy to do now because the axis of symmetry goes right through the vertex. So where is that? That's at x equals 3. So it's the line x equals 3. That wasn't so hard. Now to find the x-intercepts and the y-intercepts, we really need standard form, folks. So we're going to have to do a little foiling here. So y equals negative x minus 3 times x minus 3 plus 4. So that's y equals negative, parenthesis, foil that out, you get x squared minus 6x plus 9 plus 4. You then distribute the minus sign, negative x squared plus 6x minus 9 plus 4. So you get y equals negative x squared plus 6x minus 5. All right, cool. You can then factor the minus sign out again. I know you're thinking, well, but we just multiplied it in. Why would we factor it out? Well, it's because this 4 is now blended into the function, so it's a different factorization. Plus 5, so that's going to be negative x minus 5, x minus 1. So the x-intercepts are at x equals 5 and positive 1. So I come over here to 5 and 1, and I can put my x-intercepts. And you see, we did say this thing was going to open down, and we now have our y, or our x-intercepts. What about a y-intercept? Well, a y-intercept. A y-intercept is going to be right here. So the y-intercept is 0, negative 5, or at y equals negative 5. So I go down to negative 5, and I get that dot there. I can mirror it across because of my axis of symmetry, and I think I've got a pretty good mapped out parabola that I can sketch in here. All right, hopefully that made sense. First thing I did was, since this was vertex form, I found the vertex and the axis of symmetry. Then in order to find the y-intercept, I had to get that c value, which meant I had to FOIL it out and bring that 4 into the function here. And then I got my y-intercept. I also went ahead and factored it so that I could set each factor to 0 and find the x-intercepts. One more graph here to do. This one is given in standard form. So what is the vertex? What is the axis of symmetry? Well, there's a couple ways to do this. Let's find the x-intercepts. Let's see if we can factor this. All right, so this would be, the only way to make 14 is 14 and 1 and 7 and 2. So I think I really, this comes with experience. I'm sorry to say, 4x and x. What I realized in my head here was that 7 and 8 subtract to be negative 1. So that's how I knew to pair the 2 with the 4, because I'm thinking 8 minus 7 makes my negative 1. So I want the 8 to be the negative, and then the 7x on the outside here would be positive 7x. So that's the factorization. So the x-intercepts, therefore, are x equals 2. And if you're not sure what this one is, set it equal to 0, and you're going to see x is negative 7 fourths. Negative 7 fourths. So we can come over here to 2 and put a dot. We can go to negative 7 fourths. Now that's a pretty weird number, right? That's like right here. Okay. Does this open up or down? Well, the 4 is positive, so it opens up. Okay, what is the y-intercept of this thing? The y-intercept is going to be at negative 14. So it's going to be way the heck off of our graph. In fact, I think I'm going to count by 2. So negative 2, negative 4, negative 6, negative 8, 10, 12, 14. There's my y-intercept. So that would be 0, negative 14. So what is the vertex of this thing? Well, to find the vertex, what you have to do is average the x and y's to find the middle of the graph. So you take 2 plus negative 7 fourths and then divide by 2. That's going to give us the axis of symmetry. So that would be 8 fourths. So that's 1/4 divided by 2 is the same as 1/8. So my axis of symmetry is at x equals 1/8, which is a really weird axis of symmetry, right? So then you'd want to plug that 1/8 into the function to get your y component here. I don't have a calculator handy to do that, so I'm just going to leave it like this for you to do. But you plug that 1/8 into that function up there, and we can go ahead and sketch out our graph. Notice how narrow this graph is. The reason it's so narrow is because of that 4 out front. Now in the test, I'm not going to give you anything that's so crazy like this with one of the x-intercepts being a fraction like that. But that's just the way this one worked out. You can always check your work on Desmos, but I was able to get a pretty good rough sketch of this without too much difficulty. All right, good luck in your studying.